Okay, so it fits the concept of annuity. We call this increasing annuity problem because in his account the balance goes up every half year. Okay, so let's think about this. This is kind of an investment, correct? Okay, because when you spend the money, when you put the money in the bank, you expect the money to grow, and the question is how much? Okay, that is, in other words, how much of interest you are going to earn. So let's think about earned interest over here. Or interest earned, probably that's better. So how we are going to compute that? I didn't give you the formula. Okay, I didn't give you the formula, so let me start the question. He deposited this for 16 times. So when you make a total deposit, do you think that is going to be more than 30,000? Of course not. It has to be less than 30,000, and therefore when he receives $30,000, okay, this one includes some interest the bank is paying, correct? So how much is interest earned? That one is going to be 30,000. He got it, minus all the money he deposited. So that is 1609, 50 times. How many times did he deposit? 16 times. Yes. So in other words, this future value F minus here is total deposit. Okay. So how much is that? Once you subtract, that is 30,000, subtract 25,744, that gives you $4,256. Yes, that is $4,256. So this is the general, just the idea of how to compute the interest you earn. Make sense? This much money you receive, this much is money is you go out of your pocket, and the difference is the interest you earned. And by the way, because the numbers are kind of reasonable numbers, so this interest cannot be too much, too high. Okay, if that is too high, you are going to suspect that, oh, maybe I did something wrong here. The next one. Example 3. Here is a sinking fund. What is a sinking fund? I put it here. Increasing annuities set up by a corporation or government to repay a large debt at some future date. Okay, so we call this I was thinking about just why they call it sinking fund. I guess this is like they want to sink their debt. Okay, so let's say here a city has a debt of $1 million due in 15 years. So let's say a city government wants you to build like a parking garage. Okay, so they borrow the money, $1 million to build it, and they have 15 years to pay it off. So in order to prepare that $1 million debt, what would you do? Would you just wait for 15 years and then all of a sudden just you find all the principal and the interest all at the same time, all at one time? No, the government will be prepared. So this is their plan. Each quarter year, they are going to deposit certain amount at 4.8% interest compounded quarterly in order to pay off the debt. So how much money they have to deposit every quarter year? So that is a question mark. Okay, so here we go. The city government want $1 million in 15 years. In order to prepare for it, they are going to deposit every quarter year. Okay, so that means 4 times a year. Under this condition, 4.8% compounded quarterly. Alright, so R equals 0.048 and M equals 4. And for 15 years, so T equals 15. So what is I? I is 0.048 divided by 4, which is 0.012. And how many times they are going to deposit? That is N. N equals M times T, so 4 times 15, that gives you 60. So the city government will make 60 deposits. And as a result, they are going to have a lump sum of $1 million in 15 years. So the question mark, how much they are going to deposit every quarter year. So we compute the R, okay? So again, we are going to use this. So R equals, what is I? 0.012 over here, 1 plus 0.012 to the what power? 60, subtract 1, close the parenthesis, and then multiply by the future value. They want to have 1 million. So multiply by 1 million. Okay. I will wait for you. You compute. And by the way, when you do My Math Lab homework, well, you are going to make it as accurate as possible. And always what? Round to the 2 decimal places so that you include the cents clearly. So once you compute, it is $11,476.15. Okay, so this is R. In other words, they are going to deposit this how many times? 60. Yeah, 60 times. And then they are going to have 1 million. This is just a short summary for that. Okay? So how much of interest they are going to earn? Well, that is very long-term commitment and it's a large amount is involved, so you should expect pretty reasonable interest. So how much of interest they are going to make or earn? Well, this is their money going out of their pocket, okay? So this times this money will grow to $1 million, so interest is, that is 1 million, the difference between the total deposit, that is 114,675 times 60, okay? So that is so 1 million minus 6,885,68. Yeah. Okay. So what is the difference? Well, let's compute. So this is 8. This is 2, once you subtract, this is 1, this is 3, this is 4, this is 1, 3. Yes, this much of interest they are going to earn. Well, it's not too bad. It's a pretty good amount of interest. Okay. So, the add vocabulary sinking fund. Okay, sinking fund is, in other words, increasing annuity program. Let's go to the next concept, which is the opposite concept, decreasing annuities. So all the formulas will be changed. And they're going over here. All the vocabulary is going to be the same. So this time P equals 1 minus 1 plus I to the negative n. Yeah, be careful. You are going to have a negative power times R. Or this R equals I over 1 minus 1 plus I to the negative n times P. Yes, this formula is even more complicated than future value or increasing annuity formulas. Okay, the concept is this. Okay. Go back to page 91, example number 2 over here. Having just won the state lottery. Wow, that sounds exciting. Yes, unbelievably happy you are. Okay, here, you decided not to work for the next 5 years to travel and to write a book. Okay, you just dream about it for 1 minute, okay? You want to deposit enough money into the bank so that you can withdraw $5,000 at the end of each month for 60 months. All right, so let's see. We are going to deposit a big amount over here. Deposit some lump sum. And from here, you are going to withdraw. Well, in this scenario, you withdraw $5,000 every month. So this is not just one-time withdrawal, okay? $5,000 every month for how many years? Yeah, for 5 years. So that means how many months in here? That is 60 months. So in other words, you are going to withdraw how many times? 60 times. So at the end, what's going to happen? Well, okay, this balance goes down to 0. You have no money left in the bank. Okay? So enjoy the $5,000 every month for 5 years. In order to prepare for that, basically monthly allowances or living expenses or travel expenses, how much money you have to deposit at the beginning? That's the question. Okay. So deposit in the beginning, so we call this P for present value. You withdraw money, it doesn't matter whether you deposit money regularly or withdraw money regularly, you are going to call it the same R. Same R. And the I and the T and the M stuff stays the same. Okay? So the only difference is instead of depositing the money, you are going to withdraw money. Withdraw money. And at the end, the money goes down to 0. So in this case, yes, 5,000 was R, this is P, and 60 months, so N equals 60, and let's say 2.1% compounded monthly. So that means R equals 0.021, and the monthly makes M equals 12, and N equals 5 times 12, that gives you 60. And what is I? I is 0.021 divided by 12. Well, what is that? I didn't compute that. So 0.021 divided by 12. That is 0.00175. Okay? So these things are involved in understanding this decreasing annuity concept. So let's compute. Yeah. Example 5. I know, isn't this a happy scenario? Yeah. Well, Example 5. So how much money must you deposit now at 6% interest compounded quarterly in order to be able to withdraw $3,000 at the end of each quarter year for 2 years? So you withdraw $3,000. How much you have to deposit at the beginning? We don't know. That's a question mark. So every quarter year. So M equals 4. For how many years? Oh, T equals 4 years. So N is 4 times 4. That is 16. What is the interest rate? So 3%. Oh, I'm sorry. I mixed up over here. Yeah, 6% compounded quarterly. For 2 years. I'm sorry, over here, T equals 2. Yes, my eyes slip down to the next problem. So that is 8. This is R, so that is 0.06. So what is I? I is 0.06 divided by 4. That gives 0.015. And what is N? Yeah, N equals 8. Okay, so how much money do you have to deposit at the end, at the beginning, so that we can do this? Well, so that is, yes, this time we need P, correct? Okay, so P equals, here, 1 minus 1 plus, I is 0.015 to the what power? Yes, we have a negative 8 power. Here, I equals again 0.015 times R. R is 3,000. Yes, R is 3,000. Okay. Again, yes, because it has 2 parts in numerator. Yes. Start with opening the numerator. Opening a parenthesis in the numerator. So parenthesis 1 minus this and this. So when you put negative power, so basically this is 1 plus this, so just 1.015, that much you can do in your head. So power T, and then negative 8, so negative sign is this, right, inside the parenthesis on your calculator, 8, yes, you can do that. You don't need a separate parenthesis over here, just make it this, it will give you this. It will give you the form of this. And after that, you have to get out, so you move the cursor out of that. So how much is this? This is $22,457.78. All right, so once you put this much money in the bank, and then you can withdraw $3,000 over a 2-year period, altogether 8 times. Okay, that's the concept of decreasing annuity. As you see, the money in the beginning, it was a lot. As you withdraw money, yes, the balance decreases. That's why we call it decreasing annuity. Well, in this case, how much interest would you earn here? So how much interest? There are too many numbers here, and then it may confuse you a little bit. But altogether, what you need to do is, well, this much money you put in the bank. How much money you withdraw altogether? $3,000, 8 times, so altogether $24,000. This is a total withdrawals, correct? All right, so subtract this, 22,457.78. Yes, that one is going to be the, yes, once you subtract, you are going to have 1,542.22 cents. Yes, this much is the interest. Make sense? So when you think about the interest, just compare to the total amount where you are going to either withdraw or you are going to deposit against what? Against the lump sum you are going to have in the beginning or in the end. Once you find the difference, that's the one that you call interest. The next example. Rent for increasing annuity. Okay. If you deposit $100,000 into a fund paying 3%, so you are going to deposit lump sum, we call this just lump sum many times, $100,000 into a fund paying 3% compounded monthly. How much can you withdraw at the end of each month for 4 years? So each month, how much can you withdraw? So of course we call this one what? Rent. Okay? Yeah, withdraw how many times? Monthly for 4 years. So you are going to withdraw 48 times. So that at the end, the balance is going to be 0. Okay? So how much money can you withdraw each month? That's the concept. So let's compute. Oh, did I erase that? That's bad. All right. So here R equals I over 1 minus 1 plus I to the negative n times p. Okay? So let's compute. That is, so R equals 0.03, M equals 12, T equals 4. So we already figured out that N equals 48. Now you need I. I is 0.03 divided by 12. 0.0, I guess, 25. Yeah. Is that right? Yeah, 0.0. 0 to 0 to 5. 0 to 5. N equals 48. Yeah. Alright, so let's put in the form, put everything into the formula. So what is R? This R equals I is 0.0025 over 1 subtract 1 plus 0.025 to the negative what? Negative 48 power. And then times, what is that? P, that is 100,000. Please, yeah, just I had to calculate, just before I do this lecture so that I have very accurate answer. So I'm just, but you please do not take it for granted.